So if you've been ever curious to know what is actually inside this battery, we're having a sample battery here. This is for HP 1030G2, and we could actually see what is inside. So apart from the cells, we usually have what we call the BMS that does management for the battery. Let us go to the scope and check it out. Right, my scope is having some glares and it should be okay. So at the point of this is the point of exit. We actually have 4 wires. The 2 red positive wires and black, which is a negative wire, these are enable pins, usually this white color. Okay, then we are having this component, which is a fuse. So this plays a very critical role where it usually shorts itself out if there is a problem within the cells or within the board. Then we have the 2 input transistors. These are MOSFETs, the Q2 and the Q3. This should be the first MOSFET, the second MOSFET, being controlled by a chip here called the BQ chip, and this is the BQ4050. Okay, yeah. So normally, what could you check, or what can you check in these cases? So let's take our multimeter. Then how do you check for faulty MOSFETs in the BMS? I'll click to continuity mode, beep mode, and it's beeping. So check the drain and source for a short like that. If it's not beeping, that's okay. We're having 55 millivolts, which is okay. Here we are having 55 millivolts, which is okay. 732 ohms. I'm sorry, we're having something is wrong somewhere. Let me just refresh. Disconnect. Let me reconnect. All right. So I'm having a problem with my multimeter. Just a minute. Let me switch it off and on. Should be back. Okay. Let me shift to continuity mode. Once again, shifting. Beep mode. That's okay. All right. Let's recheck. At this point, we're having nothing. Okay. At this point, we are having 730 ohms. We should be okay again. So we can also check this fuse. If you're having a problem, you should be able to beep. Okay, in this case we are having around 0.2 ohms, which is same as the probe. 0.1 is same as the probe value, and these are pads for the battery cells. So this is ideally what you would get on laptop motherboards. I have an architecture here. Let me show you the architecture. Let me go to downloads, and I actually have the picture here. All right, I'll share my screen. So we're actually having that architecture here, and at this point we're having the fuse. In this case, this is a 10 amperes fuse, which is going direct to the system. That is from the battery cells, the positive line. Then the negative lines go directly into the BQ, the BMS BQ chip. In this case, we are having 3 cells, that is each with 3.7 volts, having 2600 milliamperes. Okay, Right, so they are connected in this series of parallels, so giving a total of 3.7 by 3. So probably we should be having around 12 volts. If you do that math, roughly we should be having around 12 volts to be able to power on the machine. Okay, they're connected to some resistors, in this case 10 kilo ohm resistors. I don't know if we'll be able to check out and see those resistors. Let me share my scope. Okay, my scope is has a problem again, and it's back. So let's try identify those resistors. They should be around the BQ chip, and I think we have them here. We have the resistors here, so we can actually check them to see if we're having a problem there. Of course, at this point they should not be beeping. Okay, that's okay. Here you're having 200 ohms. Here you're having 199 ohms. Here you're having 1,000 ohms. Sorry. Here we're having up to 1,000 ohms. These capacitors are okay, so you could randomly check if you're having a problem with any resistor. And randomly check individually the capacitors if they are okay. In this case they are. We could check out this one, and that's okay. And you could check out these caps. Remember, these caps should not be beeping. We're having another big resistor here, R0005, has actually a very small value of 0.005. So ideally we expect this one to beep. All right. Yes, it looks like probably a current sense resistor, and actually it is. I think I'm having two lines here which are running directly into the BQ chip. So at this point, at what point? There is a point where this is ground, this is reference to ground, then connected to this resistor and this resistor. Okay, this is a current sense resistor used to sense the current, and they go directly into the BQ chip. And there we have them going directly into the BQ chip. So if you're having a problem, usually the BQ chip will lock these two MOSFETs, or one of the two MOSFETs. So voltage can never pass through if you're having a problem at the cells. So at that point, you actually have to trick the BQ chip. And usually the device used to unlock those BQ chip is called the NLBA. I think I haven't purchased one. If you're so much into the repairs of battery BMS, you will actually need that NLBA. Okay, yeah. So number one, you check the fuse. Usually the fuse gets blown a lot if you're having a problem. That component labeled Y, that is the fuse, it gets blown a lot. So you could actually rebuild the fuse and the battery should work. Okay, yes, that is if the cells are okay. So check the voltage of every single cell. If you're expecting the voltage you need, that is in this case if you're having 3.7 volts on each and every component, of course, I mean each and every battery, of course, that is a working that's a working battery, that's a working cell, I mean. Okay, yeah. So I removed the cells. I don't know where I placed them. Let me try look for them. Okay, I actually didn't find them, but we can use the ones here. I can open up this one so that we use it as a sample. we need a blade. Okay, we need to feel so that you don't cut the cells. You need to feel where we're having the BMS, and at this point I think we're having the BMS in between here. So you could, it's a little bit hard. Let me try peel it from here. Okay, they're a little bit hard to peel out. You have to be very cautious with the cells. Alright, and here we have the BMS. So they're ideally having the same architecture with whatever we checked. We're having very nice cells here, each with about 3.85. We could check through the scope. So this one is about 3.85 volts. The other cell is about 3.85 volts again. And these other cells should be around 3.85 volts. So all of them are 3.85 volts. We're having a BMS at this point. Let me use my anti-glare light. So remember the BQ, we're having the same BQ chip here, same architecture. So the first thing we're going to check at this point, let's check the voltage, the VDC, in reference to ground. Okay, at this point, wait, we're having two cells. At this point, what are you having? At this point, what are you having? And we're having, wait, we're having nothing. We're having nothing. Wait, 50 maximum, then mid, then high. Okay, let's check. These should be the, I think this should be the live. Let's check again, and we're having 4 volts. Check my multimeter. We're having 4.2 volts. So that battery is okay. Let's check this other one. We're having 4.2 volts, which again is okay. And the third one, which is where's the third one? The third one is connected to, wait, how did they connect these? The third one is connected in here to this other cell. Okay, so we have confirmed we're having around 4.2 volts on this first cell, 4.2 volts on the other cell, so we should be having a unison of about 3.8. I don't know if we had some damage here, about 3.8 by 3. Okay, all right, so let's check at this point what we're having. At this point we are having nothing. You can see that. So we're having nothing. So the BQ chip has disabled those cells. And we should probably be getting around the total volts, which is about 12 volts before the first MOSFET. Okay, hope it's clear. So at this point we should be getting voltage. Is it really that point? Let's confirm. Let's confirm here. But you're having nothing. should be getting good at this point. We're getting 11.3. So we're getting 11.3 at this point, and at this point we're actually getting same 11.3. We should be nearly 12 volts, but in the output, so this is the input, and here we have the output. So the output is 0, the input of the first and the second MOSFET 11.7. Here we're having 11, here we're having 11. Okay, in the output we're having 0. So this MOSFET is switched off by who? By this guy called the BQ chip, because probably there was a problem somewhere. So you cannot actually force it. Okay, so it is being controlled by this point, which is called the gate. Here you can see we're having 0 volts at the gate of this first MOSFET. We are getting 5 volts. So these are P channel MOSFETs. Okay, because the gate voltage is lower than the gate voltage is lower than the source. Okay, source in reference to the gate, we are having nothing. How? We are having nothing here. Okay, fine. We're having 6 volts. The source we're having 11 volts. So that is how P channel MOSFETs work. If it would have been an N channel, we could be having a higher voltage than 11 point something. So we could be having probably around 18 volts at this point, with a difference of around 5 volts. And that is how this is enabled. So we are actually missing a gate voltage at this point, which should be around 5 volts, right? So Anders would try do a trick. What would happen if we supply 5 volts at that point? Okay, all right, let me get my power supply. Experiment what would happen if we would supply 5 volts. So we are actually doing 5 volts. Check my power supply. We'll do around 5.8. Let's lower the current to about 0.5. That should be okay. Then we are going to trick. So let me look for a good ground. Let me look for a good ground. What would happen if we trick? So at that point, there we have it. Let me test if it's working. So it should be okay. So let's apply 5 volts. Check for me if it's taking any current, or if we are going to explode things. Okay, and it's taking nothing. It's actually taking nothing. Okay, yeah, it's taking nothing. So it can't be enabled even if we try trick it with supplying 5 volts. Okay, so that is just a precautionary measure to help these batteries, so that if you're having a problem, the BMS is able to lock the battery completely. All right. Yeah, so we're having the same architecture. We have the resistor we saw in the other BMS. We're having the BQ chip, same architecture. We're having the first and the second MOSFET. Then we're having the series of resistors here. You can actually check them again out. So in this case, this battery has been locked. We could only use an NLBA. Okay, Then we should be having a fuse somewhere, probably at the back. Let me just confirm. It must be there. Let me confirm. Are we having any fuse somewhere? And I think we have it here. This is our fuse. You could confirm if it is working. Continuity mode, beeping mode, confirm, and the fuse is okay. The fuse is working. Here we have the label of the fuse. So the fuse is, which type of fuse is this? I've never seen such a fuse. This is not an original battery. I think that's why. This is not an original battery. But there we have the fuse working. Okay. Right. So the cells, I think two cells are okay. Having 41,000 milliampere hour. Two cells are okay, but one cell is not okay. You can see. So that is it. So you have actually learned how whatever you will do, if you could be having a problem with the BMS of the battery. Okay. Yeah. So thank you so much for watching the video. Hopefully you've learned something, and if you're having a problem with your batteries, of course this is not advisable and you should never do this at home because it's actually very dangerous. Lithium batteries are actually very dangerous. Okay. Yeah, so these are control lab, so we're having fire extinguishers here in case of anything. We could always sort out issues. Then yeah, so please just subscribe my channel by just support my channel by subscribing and liking and sharing the videos. Okay, really appreciate it. Bye.